Hello, welcome to our presentation titled Transforming Calculus Courses with Cutting-Edge Video Recording and Editing Technologies, a Case Study. My name is Dr. Natasha Gerstenschlager, and I am an Associate Professor at Western Kentucky University, and I'm going to be presenting this research alongside two of my colleagues also here at Western Kentucky University. So to give you a brief outline of what we're going to talk about today, I will introduce us to the problem. We will give a brief description of the videos that are mentioned in the title and abstract. We'll discuss our methodology and methods as well as the results, and then end with conclusions. So first off, there is a nationwide problem happening in our introductory calculus courses or Calculus 1 courses. So calculus is a fundamental course that STEM majors have to have in their coursework. In fall 2010, we had over 300,000 students across the US enrolled in these courses. Unfortunately, however, at these US colleges and universities, we're seeing high attrition and failure rates in these courses. So there is a problem with maintaining students in these courses and allowing them to be successful. In most calculus courses, there is a recitation section. Students who are in these recitation sections talk about concerns regarding the insufficiency of information and the lack of opportunities to practice learned pedagogy. If you couple this with the fact that TAs, teaching assistants who usually teach these courses, do not receive the specialized training that they need to teach those courses successfully, then we can see that we have a pretty pervasive and a pretty important problem that we need to address. So this nationwide problem, we also observed it at our local level here at Western Kentucky University. We recently surveyed students and asked our students, what could the recitation leader, the TA, have done differently to improve your performance on assessments like the quizzes? And our students talked about the types of problems that they were seeing in those recitation courses. So they wanted to see more examples and more non-trivial examples worked out in the recitation sections. But unfortunately, there is another problem that is presented. So there are many sections of calculus at our university, and each homework assignment that these students have to complete in their calculus sections is about 8 to 15 questions. However, the number of questions that a TA can go over in a recitation is usually only 2 to 4. So we see this gap between how many problems they're being assigned, how many problems they're actually getting to explore in their recitation sections. So now I'm going to share a bit about our methodology and methods that we used to address how these videos could be used to improve students' learning in our calculus courses. So we wanted to understand how these recitation videos impacted students' learning, particularly in the short term over the course of maybe one exam, and then in the long term over the course of a semester. So we collected quantitative measures, a pre and post test on these students. We also collected what we called a calculus readiness test at the beginning of the semester so that we could gauge how much information on calculus our students were coming into the class with. So although those quantitative measures provided one picture for us, we wanted to know more about how the videos were or were not contributing to learning. So we decided that we were also going to collect qualitative data, because we know that just collecting those quantitative measures, the readiness test and the pre-post test, doesn't tell the complete story. So we employed a mixed methods approach, collecting both quantitative data, the ones that I've described, and qualitative data, which I'll describe in a moment. So the quantitative measures, we used ANCOVA to assess students' calculus knowledge and their readiness coming into the course. And we did that so that we could do a comparison between two sections. So we had two sections of students, and we wanted to know at first, are these sections homogeneous? And so to be able to do that, we needed to know how much information in calculus they were coming into the course with. That's where the calculus readiness test comes into play. Then we also collected pre and post test data, like I just mentioned, to see how much growth happened during the semester and to be able to compare across sections. The qualitative methods that we collected were two formative surveys. Those surveys were administered early in the semester and then later, so about a third of the way and then about 2/3 of the way through the semester. And then we collected interviews with students. So I was the one who conducted the interviews so that the student's professor, Dr. Oz, could be unbiased in that. And the interviews followed a semi-structured approach, meaning that I had particular questions in mind that I asked students about, particularly pertaining to the videos and how they helped them or did not help them in their learning of calculus. But then I also asked other questions that came up naturally in the interview, probing questions, trying to get more information from the students. So now that we've heard about the quantitative results from the pre-post test and the calculus readiness test, and we've heard about the qualitative results from the survey, I'm going to share some of the results from the interviews. So just so you understand, interviews were analyzed using a general qualitative data analysis approach. So we interviewed students. Those interviews lasted about 10 to 15 minutes, and we looked at the responses and looked for what we would call codes. And codes are salient features, salient comments that students are making regarding the questions that I asked. And then once I identified codes, I merged those into a theme to paint a picture of how the videos were or were not helping students in developing their knowledge of calculus. So I'm really looking for saturation of ideas. So is an idea prevalent across multiple interviews? Are students talking about the same things? What are those things that they're talking about? So when I say themes, that's what I'm looking for, salient ideas. So there were three major themes that resulted from the interviews, and I'm going to share what those themes are and then a brief quote from our students so that you can see what that looked like in a response. So the first one is that the videos deepened their understanding of calculus. So here are two representative quotes of that theme. First, I think without the videos, I would be really lost. And then second, they helped me to understand it better, meaning calculus. So this was a comment that was representative of all of the interviews that I did with students. Next, students talked about how the videos compared to their TA-led recitation sections. So remember, in those TA-led recitations, they're only able to cover about 2 to 4 questions. And so during the interviews, I asked students, how does that recitation with your TA compare to these recitation videos that you're using? And so the only comment that came up regarding that was students commented about how in the TA-led recitations, they were able to ask a question immediately and get an immediate response. Whereas in the recitation videos that Dr. Oz created, they had to email the professor if they had a question. So it really was this real-time versus delayed response in terms of asking questions. But students regularly commented on how they felt that they felt that the videos were extremely effective in going over the content, and they used that in conjunction with the TA-led recitations. So they found those things to be different, but also equally beneficial. And then finally, they talked about how the videos needed variety in the problems. So one student said, I wish there was a little bit more variety. Another student said, I'd prefer them to be more complex problems. So again, we're looking at something similar to what we started off with, talking about how students really want to see more examples. They want to see more challenging examples. TA-led recitations are limited in how much they can go over. So they're looking for something extra in those videos to kind of complete the whole picture for them when they're studying.
Hello, this is Dr. Ozer, in short, Dr. Oz from Western Kentucky University. I'm going to take over the presentation at this moment, and I'm going to try talking about our solution to nationally recognized and domestically diagnosed problem. And the solution is all about having or developing short instructional videos. And to achieve that, we had to have a master plan. What do I mean by that? Essentially, when I started first doing that, before recording, I had to determine all learning objectives for each section. And I then had to determine all the necessary skills to achieve each learning objective. And then once you have these two, then you have to pick a good number of relevant exercises. That could be like a combo of trivial and non-trivial. Obviously, recitations are good sources of practice, but the available time and the number of exercises gone through during the recitations are very limited. So that's why we're choosing this path of having my own recitation videos. And obviously, since you're going to record videos, you have to have a good format of lecture notes and recitations written, because time to time in the video you can go back to the lecture notes, and you should have the same format that you use in the video. And this could be like PowerPoint or Beamer, and design color and graphical aids are particularly important in developing good quality videos. And to me, the most important part is to blend more visual aids into my videos. So I had to develop my own Wolfram demonstration projects and Desmos demonstrations, in addition to GeoGebra simulations. And I also had a lot of 2D and 3D visuals coming out of Mathematica or Desmos. And this is pretty good because whenever you make an abstract concept more reachable to students, especially when you are trying to solve an exercise, students appreciate that. And when I say like recording videos, I'm talking about recording short videos, which could be around 2 to 8 minutes, depending on what you're covering within the video. All right, now the question turns out to be how and where to record professionally made short instructional videos. When I first started recording, I didn't have much option to have professionally made videos. We had a recording studio on site at WKU, and that studio had light touch technology, light board, and green screen. So essentially, the light touch technology is a 65-inch touchscreen computer with a software called LightPen. And essentially, you have a light board, which is a glass board with a lot of lights around, and then you mark on it with a special marker. And what happens is that with the green screen technology, you erase the background. So this is a professional studio, and when you go there, you have to be very prepared because you're on your own during the recording, during shooting. So you're going to have a lot of trial error sessions over there. All right, if you have a professional studio at your institute, make sure that when you reserve your spot over there for recording, you have all the materials, PowerPoint slides, PDF, documents, simulations ready, and double check before you show up, because their resources may be limited, and editing these files during shooting is not a good thing based on my experience. The softwares usually used to make simulations may not exist in your computers, and if you want to edit something during shooting, that's almost impossible. And it may take several hours to record your best shoot. There will be lots of trials and errors, and you will see that even 2-hour reservation may not be enough at some point. And our professional studio does not provide any kind of like professional editing after shooting, so just get prepped for that and try learning at least one editing software. All right, here are some samples from the recordings at the professional studio, and you can see like how I use the glass screen and green screen technology here, and you can see that I added my own visual aids. I embedded those within the videos to be able to explain certain concepts with these videos. All right, having a professional studio is just awesome if you have one in your institute, but there are some disadvantages. First off, it's very labor dominant, and you have to be super prepared before you show up there. I was using a specific marker for that glass screen, and when you have the glass screen all filled up with math, you have to erase it for the next part of your shooting, and erasing happens with the chemical, and it's very hard to remove that. And obviously, since there's no one helping you during shooting, so you have to control everything by yourself. So instead, what I did is that I wanted to have my own recording studio at my home. I had one room that I wasn't really using, so what I did, I got, as you can see in the picture over there, so I got a green screen, I got lots of lights around, I have like 2 different computers, 3 different screens here, I have one camera recording right now, I have another one here. So this wasn't super duper expensive, but it's just like a good investment for future. And I learned one of those recording software. So right now I'm sort of like on top of these three: Cam Studio, VLC, and OBS. And OBS is the one I'm using the most. And also, you should learn one video editing software which is going to help a lot after shooting. So post-editing, I think, is more important than even recording and preparing the presentation. And I used to use iMovie a lot, but right now I'm using Movie Maker and OpenShot. But again, it depends on what you like. So please learn at least one editing software along the way. And as I said, editing is a key for post production. And not to mention, you should have a big storage space because you're talking about lots of trials and errors and everything. So I'm saying 1 to 5 terabytes, but just double that based on my experience after shooting a lot of them. And we're going to publish those videos. This is, in fact, again, another important aspect of deciding recording your sessions, right? Recording your videos. And we used to have, we do have, in fact, something called MediaSite working under Blackboard. And Blackboard has its own upload feature anyway. But those were so like platform dependent. I decided to have my own YouTube channel so that I was able to dump all of those videos within my channel, and I can make some of them public. In fact, I made so many of them public at this moment, but what happens is that if you are using your phone or tablet, all you do is click the link for the video, and then boom, you have the YouTube app and watch the video. You can even stream that through your TVs.
Hello, everyone. My name is Lukun Zheng. I'm Assistant Professor of Statistics at Western Kentucky University. Now, I'm going to talk about the quantitative method used in this study. Now, here we use the model called analysis of covariance as our statistical model. Now, in this model, as you can see, we have a Yij, which is the response, mu dot is the overall mean, tau I is the fixed treatment effects, and this gamma is the regression coefficient between the covariate and the response. And finally, this is epsilon ij, or the random error term, with mean zero and variance sigma square. Now this model, it includes what? Tau I. Now this tau I is the treatment means for different levels of the treatment. Okay, so we have a ANOVA part of in this model. That is ANOVA part. Now another feature here is we have a x value, xij. Now these xij are quantitative variables, right? Variable. Now which is called here as covariate. Now here is this gamma is the regression coefficient. Now you can see that gamma, by including this x, this variable covariates, and also this tau I here, we combined actually. One is the ANOVA part. Second is the regression part. So by combining ANOVA and the regression together, we got this analysis of covariance. Now, this model is very popular. Actually, it's because in practice, it's often the case that we have a qualitative, treatment. We can use for which is usually treated as in ANOVA model, and another part is a regression model, right? It's a regression element there. That for which case we have a quantitative regressor. Now, this analysis of covariance just combine these two together into one. Now, this model is has many different advantages over each single one of them. As you can see, by combining these two, we can do more argument, more analysis here, right? So ANOVA part and also the regression part, right? So that's one advantage. Another advantage is now by including this covariates, we greatly reduce the error variance, which often leads to more reliable results. Okay, so this is the model we used in this study, analysis of covariance. Okay, here is the quantitative results part. Now we want to answer two questions. All right, so what are these two questions? Question one, do recitation videos have short-term effects or long-term effects in improving students' academic performances? Now here, you have to be careful. What do we mean by short-term effects and long-term effects? Now you can see from the remark here, short-term means what? Just between the start of the semester till the time of the first exam. That's about 1 month. Now the long-term effects is going to be, the time span is going to be the whole semester, about 4 months. All right. So, so the question is, do the recitation videos have effects, have short-term effects or long-term effects? Right. That's the type of question we have here. The second, given the recitation videos are present, does it make a difference to have TAs? Right. So, in other words, our TAs still needed if we already have the recitation videos. All right, so let's consider these our data here. And for question one, we have the following statistic for our data based on two sections of Calculus 1 in spring 2020. All right, so here is our experimental setting. We have a control group and a treatment group. For the control group, there is no video available for these students. All right, for the treatment group, they are given the videos, all right, the recitation videos. Okay, so as you can see, the size of the two groups and the readiness, the average of the readiness score for these two sessions, exam 1 and final exam, these are all the average score they get in each group. All right, so based on the model, the analysis of covariance model, now we have the following conclusion. All right, so there is no significant short-term effects during a short period of time, like the 1 month, right, short term. The recitation videos does not play a significant role here. Whether you have video or not, it doesn't make a big difference. Okay, so that's the first result. Now, second, we do have a significant long-term effects. That is to say, now, if you are talking about this whole semester, recitation videos does make a difference. It has a significant long-term effects. So which means what? The recitation videos helps. Okay, so that's the first conclusion we get. All right, so the recitation videos have no short-term effects, but in the long term, it's effective. Second question. All right, so we have the following sightings again. Here, this is the two sections of Calculus 1 in fall 2020. The control group, no TA, but with videos. Treatment group with TA and the video. All right, basically is to see, we want to see what, given the video is present, whether the TAs has an effective role here or not. Okay, so here are some statistics about these two groups. You have the size, readiness test, exam 1, and final exam. Now results, all right? We have the following conclusions. Now, there's no significant short-term effects for the TA, all right, for the TA. That means what? in the short term, TA doesn't help much. But we do have the second results, all right? There is a significant long-term effects, all right? Over the whole semester, the effect of having a TA kicks in. In other words, a TA does make a difference in the long term. All right, now there is something about this results. All right, as we can see, we have a smaller size. All right, so size is 21, 29 here for the control and treatment groups, respectively. Now, and also for the first question, the same thing, same case as well. These results, even though it's zero significant, it is our plan, all right, in the future to increase the data size so that we can get more reliable conclusion about this effectiveness of the video, and also for question 1 and question 2. Okay, thank you. That's our quantitative analysis. Thank you very much.
All right, let's quickly talk about formative course assessment surveys. So what is a formative course assessment survey? First off, it's an anonymous questionnaire given to my classes online twice a semester, and I use Blackboard to conduct that. And it's like the questions are all about the course delivery, teaching methods, the TA, myself, and specifically the effectiveness of the videos. And it was particularly important for me to make sure that my teaching strategy, especially with the video content, works well with my students' background. And obviously when I do that, students feel respected. And I give out 2 surveys in a semester. One is given around the 3rd or 4th week as an early warning for me. So I collect the meaningful feedback and I can see if there's anything to be changed. I can if there are, I try to change them in a positive way. And I share the data with the students, and the course delivery is adapted. And I give out another survey around the 10th or the 11th week. This is my control or checkpoint, so that based on the promised changes after the first survey, I sort of like check back with the students if these changes are recognized. Do they still complain about the things that they were complaining in the first survey? And here are some sample questions from the assessment survey that we conducted in spring 2020. And just to give you an idea about what kind of questions we ask, if we asked students if they did anything else while watching and listening those videos, if they experienced any technical difficulties, if students are satisfied with the design, format, and medium of the instructional videos, as well as the visual clarity. And the length was something important for us because we tried to keep the length between 3 to 8 minutes, so we were checking if students were okay with that. And we asked if they can, if they like that, they can pace their own learning with the instructional videos. If they liked seeing their teacher in the videos, if the instructional videos contributed to their achievement of the learning objectives for each section, and we asked how many times they watched the videos and the purposes for which they used the videos, and if watching instructional videos were aligning with their learning preferences. And also, finally, we were asking if they fast-forwarded portions of the video. And we're going to submit our paper after this presentation. Please check for more details about this type of feedback from the students. So in conclusion, to be able to answer the 2 problems that we asked in the beginning about the effectiveness of these videos, we got to collect more data with pre-test and post-test. So the next year for fall and spring semesters, we're going to have more sections of calculus coming in, and we're going to hopefully collect more data. We're going to have more demonstration projects, Desmos and GeoGebra simulations needed, and students ask for it. And obviously we need more videos with Wolfram demonstration projects to be recorded along the way. please check out the sample videos at my YouTube channel. I have over 500 videos over there, and if you have any questions or comments, please send those to our way. Thanks for watching. Bye.